Welcome to the wonderful world of math, and today we are looking at lesson 58, all about symmetry. As we look at symmetry today, we're trying to understand two ideas. First of all, what is symmetry and how to develop what are called lines of symmetry. And then the second idea is what's known as rotational symmetry. And as we work at these two ideas, we'll come away with an understanding. Hopefully this is mostly review. But let's take a look at this concept just to clarify anything that might be missing. We take a look at these two shapes. We'll start with the rectangle on the left. Symmetry is all about being able to divide something basically in half so that when you fold it over that line, the corners will match up, the two halves will be equal to each other. So with a rectangle, we can talk about this. I could take a line like this, and it's off just a little bit because I started in the wrong spot. But if I had a line like that, I could draw it, and if I were to take the two sides, if I were to take this side and fold it over to this side, it would match perfectly. At the same time, I could take a second line of symmetry and go about halfway through there. My scale is not so great right now. Looks like I gotta move down. And if I were to start here and fold it over that second line, my star line, I would also match. So we would say that a rectangle has two lines of symmetry. Now symmetry can go, can just be one line. Just can fold it in half. It can actually increase depending on what kind of shape it is and how things match up as you fold it. For example, as we look at this regular hexagon, we can see that a regular hexagon is going to start to be able to be folded in lots of different places, right? Where in the end, even though my lines are not lining up that great, I gotta get better, I guess, at lining up lines when I'm, there we go. As we're going through this, there's lots of different ways to fold this shape and still get symmetrical ideas, right? Now those are some of the lines, but that's not actually all the lines, right? The corners can be a great way to start, but I also can go here and fold it in half that way, which means I can fold it in half this way and fold it in half. Well, that's not a very good half line, but like that also. And so in the end, we would talk about the fact that we have 1, 2, 3, 4, 5, 6 lines of symmetry, right, that allow a hexagon to be divided and folded equally. So we have all these different ideas. All right, let's see if you can figure out how many lines of symmetry these shapes have. So you have a triangle and you have a star, right? Making sure you pay attention to the shapes themselves. All right, go ahead and do those. Oops. All right, the second idea here is what's known as rotational symmetry. Rotational symmetry is being able to turn an object, and as you turn that object, every time you turn it, you get the same image, right? To understand this, we have, I've added some numbers to this, and we're going to take a look at this as we work with this. All right, so we start with our initial shape, and right, if I were to take a second one, and now I'm going to rotate it like this. Right, so I've rotated it so many degrees, and my equilateral triangle is now the same. But as you notice, the numbers are in different locations. And so that is one turn or one order of symmetry. Right? And if I were to take another one, hopefully you've guessed, since this is an equilateral triangle, that I can turn it like this, and hopefully I line it up correctly. And once again, I've turned this, not quite parallel. I've turned this enough to understand that this equilateral triangle has three orders, right, or three ways. So we have position 1, position 2, position 3 as we're working with this idea, right? And so each turn, usually you can figure out the degrees of a turn that you actually took to be able to figure this out, right? And so to turn it from this figure here to this figure here, I had to go 120 degrees. Right? So 120 degrees, 120 degrees, and then to go back to the original image would be another 120 degrees. And because it's rotational and we can think about everything, right, 360 degrees is going to be a complete rotation. All right. And so we have that idea. So a shape doesn't have rotational symmetry if it can't be turned within that 360 degrees and get a matching figure. Right? Then here is some quick samples for you to work through, see if you can figure out the rotational symmetry. And while this little explanation is a great start to this lesson, we're going to do some brief activities in class to help us understand symmetry just a little bit more. All right, that's it for lesson 58.